This week is RSAC in San Francisco, California, and as I walk around the exhibition space, I see all these vendors with calls for AI or MDR and zero trust. And I'm just going to say it, but I think AI is both a misnomer and a transient fad within the security industry. Yes, we need pattern matching to filter out the false positives. I get that. But AI? I think that's just a marketing term. Then there's MDR, Managed Detection and Response. It's just another short-term fix of getting around to the long-term solution someday. And then there's Zero Trust. Well, Zero Trust, that's been around for a while, at least 15 years. And in this episode, I'm actually talking to the person who first coined the term in 2010. Zero trust is a concept that you can't trust anything, and you need to authenticate and authorize each use. So what about OT? That's a different beast, right? Well, it seems that there actually is a play for zero trust in our OT systems. And why not? They're generally wide open, and legacy systems, they can't always update. This is a story about applying zero trust to OT systems. I'm Robert Vamosi. This is Error Code.
I am John Kindervag, Chief Evangelist of Illumio and the creator of Zero Trust. Illumio is a company that creates microsegmentation technology used in modern networks, whether they're in clouds, on-premise, or on endpoints. And we have recently enhanced it with new visibility tools leveraging artificial intelligence capabilities.
So I'm just going to start right out. What is zero trust?
My definition of zero trust is that it's a cybersecurity strategy designed to do two things. The first is to stop data breaches, which is when sensitive or regulated data has been exfiltrated from our hands into the hands of malicious actors. And then the other thing it does is it stops other cyber attacks from being successful. Those are the two focuses, and it does this by eliminating the concept of trust from digital systems.
And John, he coined this term back around 2010 at Forrester. Now, that was an interesting time because we were still moving away from the perimeter idea. There was this de-perimeterization going on in the network space. And there were a lot of groups like, say, the Jericho Forum and others that were talking about it pretty heavily. So I wonder, how did John hit upon the term zero trust?
In firewall technology in the day, every interface that you plugged a cable into had a trust level. The highest trust level was the internal network. It had a trust level of 100. The lowest trust level was 0. It had it was for the external network or the evil internet. And then every other interface had to have a different trust level between 1 and 99, and they couldn't be the same. And this determined how policy was built and created, and a lot of it automatically. So you needed a rule to go from a low trust level, the internet, to the internal network, a high trust level, but you didn't need a rule for a packet to move from the high trust level, the internal network, to any other low trust level, which would have been all the other interfaces. And I thought this was silly, and I kept trying to put outbound rules into firewalls that I was deploying, and I kept getting in trouble by the clients, by the vendors, and by the company I worked for, who eventually eliminated my job for trying to do that. And I said, this is insane. Trust is a human emotion. It doesn't belong in digital systems, and the trust level of every single interface should be 0, and that's where zero trust comes from.
So we actually experience it in the IT world all the time. I mean, anytime we're trying to access an asset or anything, there's always that authentication required. And sometimes it's a token, sometimes it's a certificate, and it's already done for you. But nonetheless, that's how it's played out in the IT world.
It's more than just authentication. It's also then a policy has to be set up somewhere between layer 2 and layer 7, right? So you authenticate, and then that authentication ties you to a policy. And so the policy is the thing that's ultimately important, whether you're allowed to or denied access to a resource. And those are the only things that you can do in IT, allow something or deny something. And zero trust starts with a default deny policy where everything is denied and you just turn on specific allow rules. And authentication, authorization, identity, all those things are some of the signals we use to determine what policy should be assigned to a particular asserted identity.
So that's in the IT world. The OT world, well, that's been different. OT pre-exists the internet in many ways. And so the theory that you had to log in and so forth wasn't quite baked into devices that were set in the field to work for 20, 30 years.
Yeah, I mean, the old OT world is phenomenally insecure because a human being had to go directly to a device to get access to it, right? And the reason everybody wanted to put these things, SCADA systems were the first ones I was familiar with, onto the internet or onto a network, was to make remote control possible. So I was actually involved in one of the first projects turning asynchronous serial connections for SCADA into TCP/IP, by kind of kludging up some routers so that we could control SCADA systems in East Texas with, from Dallas here where I live. And it seemed like a good idea at the time, but like any idea, there's unintended consequences. And one of those consequences is malicious actors from across the world can shut down your power grid. And this happened in Finland. I was just in Finland earlier this year at a NATO convention. And I was reminded, because it was really cold in February in Helsinki, but I guess the hotel rooms and the meeting space is much less expensive. And I was reminded that a number of years ago, Finland's power grid went down because of a cyber attack, and they kept trying to mitigate it. So what did they do? They eventually unplugged it from the internet, and it all came back up. So it's the law of unintended consequences, right? And we don't typically think about what is the downside to something we're doing. We only think about the upside.
And now we're connecting those systems, and they weren't really designed to be connected in the first place.
When we're deploying zero trust, we start with defining the protect surface. What do we need to protect? So I can put an OT or an IoT systems in some way into a protect surface, or the system itself, right? Maybe not a particular device. Some of these older things, they don't have any operating system. All they have is BIOS. You can't deploy security technology onto the device. I did 50 million smart meters for a country once, and the only thing that could be installed on them was X509 certificates, and they came with like 15 of them, and no one knew what they did. So what we ended up doing was looking at the potential problems, and we put the control system for the smart meters, which is the most oxymoronic name of all time, because they are the stupidest thing ever, right? They are dumber than a bag of rocks. But what we did is we were worried about the smart meters attacking the utility, so we ended up putting the control system for the smart meters into a protect surface and then put the policy around it. And this was before the Mirai botnet happened, and we were kind of seeing that kind of thing had happened, and it was very successful. So you have to look at what you need to protect, and then what can you do to protect it. And there's certain things that I can't protect, right? So if I've got a manufacturing line that's running Windows XP, but the PLC is 25 years old, I can't upgrade the OS because there's no driver made for that PLC. And it's billions of dollars to replace all those PLCs, and nobody's going to do it for business reasons. So what do? I figure out how that system connects to the manufacturing line, and I put the specific controls in place to control access, both who gets access and what protocols and what messages can be sent to it and how it goes outbound. And then that system goes into the protect surface. And by understanding the concept protect surface, you can always apply zero trust concepts to the problem.
So, what does John consider to be the protect surface?
Is made up of DAS elements. So data that's sensitive, applications that use sensitive data, assets that are sensitive, that's where IT assets go, but also IoT and OT assets like PLCs, HMIs, whatever. And then services like DNS, DHCP, Active Directory, Network Time Protocol. So you take a single DAS element and you put it into a single protect surface, and then you build out your zero trust environment one protect surface at a time. So zero trust becomes three things. It becomes incremental. We're doing it one protect surface at a time. It becomes iterative. We're doing it one after another. And it becomes non-disruptive because the most you can screw up is one protect surface.
So, is there a push now to get zero trust into OT, or is it still something that's just being discussed? It's not exactly regulated, right?
Well, it shouldn't be regulated, right? And it shouldn't be mandated. I mean, we don't have standards in cybersecurity. We have guidances that sometimes are called standards, but you have to do what's right for your organization, and you have to have a little creative thinking around it. And I've been doing OT environments, zero trust for OT environments for 15 years at least, probably even before that, because there were 2 years of primary research before I published the first paper. So it wasn't like, here's an idea, I'm just going to throw it on paper like, I'm a journalist or something. No, I was an analyst at Forrester, which has more rigor probably than academia. And so I had to do 2 years of primary research in order to prove that this worked. And I was designing prototype networks by this time. So I've been doing this for a long, long time, and people still reach out to me on LinkedIn. You can never do zero trust for OT. And then I can show them videos with all these OT experts talking about it, where I've done conversations with it, and I've been endorsed by manufacturers and lot of things like that. So I think the OT world is the most legacy world that we have in the world of networks. Everybody's still stuck on the Purdue model, which was created in the 80s before there were networks, right? So when I hear people talk about the Purdue model, I'm like, that thing just, I mean, it's like on life support, but people want to keep doing the CPR on it and keep it alive because that's the way we've always done it, and that's the way we've always done it, or however many words that are, but those are the worst words in the human language. That's the way we've always done it, really. So that's always been the biggest complaint about zero trust, which is that's not the way we've always done it. And people don't like when you move their cheese, even when you move it and you give them more cheese and it's better quality cheese, and you throw in some other charcuterie elements and put it on a nice board, they still don't want it because they want their old piece of moldy cheese that's sitting in front of them, instead of having to get out of their chair and move and go to the nice restaurant where you can get the lovely charcuterie board with some good French brie and some Dutch Gouda, as you actually say it in Dutch.
I realize this varies industry to industry, but in John's experience, how many of the OT systems typically are being managed with controls and zero trust versus those that are still naked and wide open?
That's an unknowable thing, right? I mean, we don't have statistics in our world that we can use to make even an educated guess on all those things. People don't have to report on all that stuff and everything. But in my experience, it's very low. Very low in terms of OT security because it works, and that's all that people care about, right? I mean, in cybersecurity, we have this concept of the CIA triangle. You know what I'm talking about?
I do.
Which I just discovered recently was invented by Kanye West. You can look on the internet and you can see him going, "Whoa!" But it was supposed to be an equilateral triangle, right?
Yes.
And it's not. What is, of all those three things, what is the only thing people care about? Right? It's availability. So that it's now an isosceles triangle with this really long hypotenuse that's an A for availability. And then integrity, no one even knows what that means anymore. I mean, that's pretty much been solved through hashing and other things. And so that leaves C, confidentiality. But I think because we're so worried about availability that now the C has turned to compromise. So we have a lot of highly available yet compromised networks. And we can see that in the dwell time statistics. I think it's over 270 days last year for dwell time. Well, that's unbelievable. And almost never does the compromised party discover the attacker. It's almost always discovered by a third party, whether that's a credit card company, or a lot of times customers discover it because something anomalous happens in their world. So you'll see places where we've had dwell time of 20 or 30 years. Citrix, Nortel. Nortel went out of business because it was hacked out of business and nobody knew. So we don't have these good statistics, but when all you care about is it working or not? Is it running? As one friend of mine says, unexplained uptime could be symptomatic of a critical cyber incident. And so, your network shouldn't be up all the time, right? It's very fragile. It should go down under normal circumstances. And if it's not going down, why is that? I know of cases where the networks have been re-engineered by the attackers to make them work better so they could exfil data better. And everybody's just going, wow, look how fast Facebook is. And because that's really what networks are for, right? Just like when I was young, we built networks so we could play Doom. That was the major reason networks were originally built, so that all of us IT nerds could play multiplayer Doom, which is why Doom is the only video game that has an assigned port number. So, Robert, what's the assigned port number for Doom?
Okay, I don't know that about Doom. I do know that it's been put on IoT devices, and it's become kind of a meme within the industry to show Doom playing on a internet-connected toothbrush. So what is the port number?
666, of course.
Obviously, 666. Well, there you go. So when I was studying for the CISSP, I always found that availability was one of the more abstract parts of it to me. I guess I just assumed that the devices would always be working, so availability wasn't as interesting as integrity or confidentiality. But that's because I was viewing it from the IT world, and not from the OT world, where availability, of course, is going to be very, very important.
If you're viewing it from the business world, all you care about is availability. 5 nines, 5 nines, 5 nines. That's what you get judged on, right? And if it goes down, then you're in trouble, even if it went down for a good reason. So if you look at something like the Target data breach in 2013, there were people going, we should just shut down the network. We can't do that. It's Black Friday. We'll lose money. Well, they lost more money than they made because they didn't shut it down. And my wife made me quit watching the TV show 24 years ago because there were constant cyber attacks in there. And I would just say, unplug the router, shut it down. I'd be yelling at the screen. She's like, you can't watch this TV show anymore. So, a lot of times the best solution is to unplug. And so it's not that hard. I mean, there's going to be a disruption, but, we lived without email once upon a time. And I think you and I can remember those days, right? And we lived without email. We lived without all these things, and we can live without them again. And because the consequences of what might happen if we don't respond to these things properly and quickly is really bad. But people are afraid to respond to cyber incidents quickly because what if they get it wrong, right? So, what if they stop good traffic? And I've always said, well, no big deal, but everybody's afraid to. So everybody's managing their own downside risk and not managing the upside potential of the organization they work for. As one friend of mine says, one oopsie eliminates 1,000 attaboys, right? So we're always looking for what's going wrong and who can we blame. And for me, I'm never freaked out when things break down because I know how this internet was built. I was there. I watched it. And it's held together by what we call Texas engineering, which is bubble gum and baling wire and duct tape and super glue. And if it breaks down, okay, let's go fix it. But it is going to break down. That is just the nature of it, and you can't sweat that. But there's too many people in charge right now who don't know how networks work, who don't understand what we're doing fundamentally, and that is crazy to me. right? And I don't get that, but hey, I'll tell you a story since this is a narrative podcast and you might enjoy this story, and I don't know if we'll make it in, but I was talking to somebody, an executive at a company, and this person was saying, well, zero trust is really network focused and I don't have networks anymore. And I said, really, you don't have networks anymore? Nope, all our stuff is in the cloud. Okay, well, it's still applicable. Well, no, it's not, because there's no networks in clouds. There's not? Really? That's news to me. I thought there were networks in cloud. Nope, they're just clouds. Okay, great. And this person said, there's not even servers in the cloud anymore. And I said, there's not? Really? There's no servers? Yeah, haven't you heard of serverless? And the way the person said it was so derisive, like, haven't you heard of serverless, you complete moron? And I said, yeah, I have heard of serverless. Where do you think they store the data? Oh, it's stored in DNA. I'm like, wow, you've been watching some weird science fiction Dark Mirror or something. I don't know, but you clearly don't know fundamentally how this whole process works, but yet you're in charge. And that is one of the fundamental problems that we have today, is there's a new generation coming in who is is large and in charge, but doesn't know how it works. So yeah, they're making bad decisions.
So John just said the target breach might have been mitigated by just unplugging it from the network. With the OT world, oftentimes that's not possible.
Yeah, it is possible, and it has happened. And in the OT world, there's a lot of systems that when you unplug them from the network, the system will still function, right? And you just won't have the real-time monitoring and all the cool dashboards and all that kind of stuff. And you might have to go out to the oil rig or the wind farm and kind of look at things locally instead of remotely. So usually, I won't say usually, but there's still a lot of cases where even if you unplugged it from the network, the system would be functioning. It's just you wouldn't have visibility into it, which freaks everybody out. But again, that's kind of your problem because you chose not to properly secure it. These are choices people make. Cybersecurity is volitional. You have to make a choice to want to do security. And there's so many people who don't. I've talked to people. I talked to one leader who said, my job is to just move packets. I don't care whether they're good packets or bad packets. Well, that's kind of a myopic view from your company's perspective, isn't it? Yeah, but I don't care about my company. I care about my job. And my job is to move packets. Oh, well, good. I'll make sure I don't do business with your company anymore, right?
So on Error Code, I've been talking to a lot of people about the water utilities and the ransomware that's affecting them, particularly the smaller water utilities. And one of the things that was emphasized to me was that they were having drills to show the team how to run the water utility manually, because they've come into an entirely IT-driven environment. And when ransomware comes along, they've got to pull the network down. It's exactly what we're discussing. But sometimes they don't know how to run it manually. Is there a need for that in the OT world, to go back to the day when you didn't have connectivity and just see if you can run everything?
Oh, absolutely. I mean, people are putting too much faith in all of the automation. I'm a huge fan of automation, and I believed in automation for a long time, and I've written about it for a long time. But at the same time, you better know what to do when disaster strikes. I had a concept at Forrester and wrote about it called planning for failure. You have to plan for failure, right? We tend to think about planning for success. What will make something successful? And then we'll do a lot of planning and project management. How do we plan for failure? We don't think about planning for failure, but it's a huge concept in my world. What are we planning for? What failures could happen? Trying to diagnose the potential things. You'll never get them all right, but like at the smart meter deployment, that's how I was thinking. What could go wrong here, right? And because of how the system is built, this system could attack you and bring your whole utility system to its knees. Grids are very fragile. And if you understand how electricity works, because before I was doing this full time, long time ago, I did data center power and other power design systems. And so I understand how electricity works, and I understand it experientially because I've been blown across a room when suddenly I became the ground for a whole system, and boy, that'll shake you up, you know. Uh, there's nothing like flying 20 feet backwards in the air like it's some movie stunt. But so you have to understand how these things work, and you have to understand what the particular failure points might be so that you can plan for that failure so that you can escape the failure, right? And it's a lot like warfare. I was never in the military. My dad was, but when he was in war, he was in the Korean War. Their main thing was, how do I escape if there's an ambush, right? That was the first thing they were thinking about, right? And I think that that's kind of a little bit how you need to do it. And so the NSA wrote some guidance on using zero trust in the network and environmental pillar, it's called, and we'll send it over to you. But they referenced the 2013 target data breach, and they point out that the reason that happened wasn't because the attacker was able to get in through the HVAC system, which is a true statement. It was because the HVAC system was on the cardholder data environment, which is a violation of the PCI DSS. And as a former QSA, I couldn't imagine giving somebody a report on compliance, a clean report on compliance, if the HVAC system was on the cardholder data environment. But they point out if that would have been properly segmented, that attack on the HVAC system would not have been able to radiate or extend into the cardholder data environment. And again, that's why planning for failure is such a big concept for me, and why I got into segmentation in the first place and started talking about it again in 2010, because segmentation mitigates a multitude of sins, and you can get your HVAC system popped, but still mitigate the blast radius, and so the explosion isn't very big. And yeah, there's going to be explosions, but you want to have those controlled, like so they become a firecracker instead of an atomic bomb.
So back when John was coming up with Zero Trust, I was actually trying to title my first book, and I was playing around with the idea of the dark side of convenience. We landed on When Gadgets Betray Us, much better title. But my point is, having that flat network is convenient because you can always access the data and do whatever you need to do. But to John's point, we need to go back to segmenting things. And people still see that as, well, that's a silo and that's too complicated. Well, you know what? You don't want to tear everything down every time you get a ransomware attack, do you?
You know where that really comes from historically, because there was a move towards segmentation in the early 2000s, probably. It was basic layer 2 segmentation with VLANs, but still there was a move to it, and there was a push to use VLANs better and do trunking better and not have everything all on the same trunk and yada, yada, yada. And then VMware came out with ESXi, which was cool, right? And then everybody's going to that. And I built one of the early full data centers, fully virtualized. And it was a pretty fun project. And we weren't thinking about security really at the time. But then VMware came out with vMotion. And everybody found that if they wanted to move a VM from one virtual host to another, they couldn't do it because it couldn't cross a layer 3 boundary. So they started flattening out the network. So the original movement that was moving towards segmenting networks was completely taken away because vMotion at that time it can now, but it couldn't cross a layer 3 boundary. So, oh crap, we can't move this VM. So, tear the network down. We need convenience. And I think your title is good. Convenience leads to compromise.
It's something that people don't want to hear. But every time someone's like, oh, it's more convenient, I'm like, okay, but what are the security consequences of what you just said?
It's true. It's sad, but it's true.
So not only is there connectivity to be dealt with, but there's also the issue of the cloud, which is starting to impact OT as well.
There's a Cloud Security Alliance project around Zero Trust. So yesterday we just had a review of the IoT report that we're issuing. We've already done the OT. So the Cloud Security Alliance, first of all, Zero Trust is unique in cloud security because it's the only thing that the Cloud Security Alliance does that also deals with on-premise technologies. But Zero Trust encompasses all things IT, OT, IoT, anytime a packet moves. And they're also the one sending it out to the rest of the world because so much of the guidance is really US government focused. And when you go to Singapore or Australia or Ireland or London or the Netherlands, like I'm going to here in a month or so, sometimes they don't want to do what US guidance says because it feels it feels like dad's telling them what to do, right? So there's a little bit of we want to come up with our own thing. And so the Cloud Security Alliance is maintaining the integrity of Zero Trust and really making Zero Trust accessible to the rest of the world.
And what are some of the recommendations that CSA is putting forth?
Well, generally, everything is done based upon the 5-step model of Zero Trust. So this is something I created out of my experiences deploying Zero Trust. And I sat down and I did a debrief to myself. It was a pretty boring conversation, really. But I looked at all the Zero Trust environments that I designed up to that point, and I said, what do they all have in common? And I realized they all had 5 things in common. So the first thing I did is define the protect surface. I asked, what do we need to protect? The second thing I did is I mapped the transaction flows. What's going on in the network? How do packets move? How does the system work together as a system? The third thing I did then is I architected the environment. So instead of starting with the technology, which I always done as a network engineer, I'm going to put a router here and a router there. And then, I don't really care where you plug things into. Just plug them in wherever you want. I made that step 3. So it was much more tailor-made for the thing I was protecting. Step 4 then becomes policy. And I created a new way to do policy called the Kipling method, where we look at who, what, when, where, why, and how. Rudyard Kipling gave that to us in a poem in 1902. So it's a personal homage to him, but it's easier to say than the who, what, when, where, why, and how method. And so who should have access via what application? When should that access be allowed? And it shouldn't be allowed 24/7, which is how we create all rules. But we need to have time limited rules so that when people who don't normally access that rule can't have access to that rule. Where is the location of the protect surface? So absolutely you need to know that. Why are we doing this? So you can put metadata in a packet, which is super cool. And that metadata can tell you a lot of things. It can show you what kind of compliance mandates that you have. What is the data classification of the packet, all the just a ton of things that you can put in there that now we're starting to utilize in AI for the 5th step, which is monitor and maintain, where we take all of the telemetry generated by this environment and we re-inject it back into the system to make it stronger and stronger and stronger. So while everybody else is talking about resilience, I'm talking about going beyond resilience into anti-fragility, where we look at how to make the system stronger under load, under attack. Those are lessons that you learn. So I'm riffing on Taleb's book, Anti-Fragile, where he talks about systems that gain from stress. So, and a good example is the human body. When you during the holidays, I don't know if you're like me, but I always eat too much. And so I gain weight. Well, what do I have to do? I have to stress my body by restricting calories. That's a huge stressor to your body. I have to, do some sort of exercise and burn off those calories and that weight. And all those stressors don't break me down. My body responds to that. It adapts and gets stronger and stronger over time because it's an anti-fragile system. And the Zero Trust environments I design are anti-fragile as well.
So is anti-fragile another way of saying robustness?
No, it's robustness means like there's a lot of people use the example of a window and a rock. A rock is robust, a window is fragile, right? So we have fragile and robust is typically how we think of systems. So if I throw a rock through a window, the window breaks, but the rock typically doesn't break unless it's going down 20 stories, right? But imagine that if the rock went through the window broke and rebuilt itself so it was stronger automatically. That's anti-fragility.
I'd like to thank John for coming on the show and talking about the origins of zero trust and how today it's being applied to OT. Hey, if you're enjoying Error Code, tell a friend. I'm sure there are other people out there who like narrative information security podcasts. And I'd really like to hear from you. Go to errorcodepodcast.com to get more details. And tell me what you like, and even what you don't. I've got some great episodes coming up. I'll have more on hacking water facilities. Subscribe today. I don't want you to miss out.